Hello everyone, it's me Gagan Kumar present over here to teach you physics. Let's move on to the video. Today we'll be discussing refraction of light. So what is the refract index of a medium? Refractive index. The refractive index of a medium basically what? It is the characteristic which decides speed of light in it. Okay. So that means there are so many material medium we have. Suppose we want to study optics thing and all, we need to understand what is refract index of that medium. Accordingly, you can understand what is happening to light. Light speed increasing, decreasing, how much speed is coming inside that. So this type of idea you can have. Okay. And here this basically types you will understand. So here two types basically, one is absolute refract index, one is relative refract index. Now what is absolute refract index? Now when light ray passes from air to any transparent medium, then refract index of a medium is called basically absolute refract index. That means, and here, so light is going, this is suppose air medium, now light is coming from air going to some medium, okay. So then this type, when this type of thing is happening, that time whatever refract index will define, that refract index basically absolute refract index, okay. That means what I can tell? I can tell refract index symbol I can give eta, like this one I can give, okay, or someone can give mu also, no issues, okay, sometimes you can give mu, okay. Now here what is this? Now light is coming from air going to medium, I can write like this, coming from air going to medium, or I can write eta only medium, that means I can understand it is coming from air only medium written, or I can write C by V. What I can write? C by V. What is C by V? C is nothing but that is basically speed of light in vacuum or air, speed of light in air medium divided by V is what? Now V is nothing but same speed of light in the medium, speed of light in medium. Okay, this is your absolute refract index. Okay. So a light is coming from air to medium or only medium, that is C by V. So speed of light in air or vacuum, remember vacuum speed is 3 into 10 to the power 8 meter per second, and in air also same thing, actually it is same thing you can consider, little variation but same you consider, and V equal to speed of light in any medium. So this is the idea or understanding. Now come to the relative refract index. What is this? Now when light travels from medium 1 to medium 2, then what you call basically, now relative refract index of medium 2 with respect to medium 1 is called basically now when light ray travels from medium 1 to medium 2, refract index of medium 2 with respect to medium 1 is called basically relative refract index. In this case, light is not coming from air to medium 1 or medium 2, not like that. Okay, light is what coming? Light is coming from certain optical medium to another optical medium. Okay. Now here this one if you want to define, you can define like this one. Light is coming from one medium to two medium, I am writing like this. Remember, light is coming from 1 to 2, or I can write eta 2 1, that is also correct. 2 1 like that I can write, or I can write eta 2 by eta 1, this also I can write. Okay. So this is called basically what? Now refract index of medium 2 with respect to medium 1, or it is called relative refract index. Okay. So this is idea you are understanding what is relative and what is absolute. Absolute means light is coming from air, relative means light is coming from where? Coming from one medium to another medium. Now we will go for the same understanding. Okay, we will go here, some example we will see, some example of refract index. Now suppose light is coming from air to water medium, light is coming from air to water medium. Okay, then here what will write? Now here I can write refract index of air to water, or it can be written as water also, only water also, or water air, like that I can write. So what is this one? Now this is nothing but, so speed of light in vacuum divided by speed of light in water, Okay. Now here what I can write? I can write this refract index of water is nothing but speed of light in air medium, remember 3 into 10 to the power 8 meter per second, and in water medium is nothing but it is 2.25 into 10 to the power 8 meter per second. Okay. Now here if you check this one, now eta water, how much coming? It is coming 10 to the power 8, 10 to the power 8 cancel, meter by second cancel. So it is 300 by 225. If you will cancel this one, you will get around 4 by 3 or 1.33. So refractive index of water with respect to air, which is basically absolute refractive index, is 4 by 3 or 1.33. Okay, this is air to water. Okay. Now suppose I am finding in the absolute refractive index, let me understand. Suppose light is coming from air to glass. Air to glass coming, that time what I can write? Now water is coming from air going to glass. Okay. Or you can write only glass medium or glass air medium, that is how much? C by velocity of light in glass. Okay. Now understand one thing here, eta glass or refractive index of a glass medium is nothing but 3 into 10 to the power 8 meter per second, and V glass is nothing but that is 2 into 10 to the power 8 meter per second. Okay. So velocity of light in glass medium is 2 into 10 to the power 8, in water medium 2.25 into 10 to the power 8. Now here if you will calculate, how much you will get? You will get, okay, refractive index in glass medium is, so 10 to the power 8, 10 to the power 8 you get cancels. Now here 3 by 2 is 1.5, or you can write 3 by 2. So this is your refractive index in glass medium. This is the refractive index of water medium. This is your absolute refractive index. Similarly, we can calculate, and directly I am writing this, everything I am writing for absolute refractive index. So absolute refractive index of diamond, you want to write for diamond, then it is basically 2.4, remember, for a diamond, and another 2 I am writing refractive index, absolute refractive index for crown glass, and one is refractive index for flint glass. Crown glass and how much? Flint glass is 1.6 around, and crown glass is 1.52 around. So this one you remember, this is the refractive index of different medium, and this you are telling with respect to air. So this is absolute refractive index. Okay. So one is absolute refractive index, one is relative refractive index. So here you are understanding absolute index is diamond, crown glass, flint glass, okay, water, and only normal glass 1.5 or 3 by 2 normal glass. Okay. So this is the idea about your refractive index of absolute things. Now you can find also, you see, I already given refractive index of a diamond I have given. Suppose you want to find velocity of a light in the diamond, then easily you can find velocity of diamond is how much, easily you can find, that is nothing but that is your speed of light, that is 3 into 10 to the power 8 divided by 2.4. So 3 into 10 to the power 8 by 2.4 is nothing but that is your velocity of light in a diamond, inside the diamond it will go. Now we understand here relative refractive index. So relative refractive index example when we will give, understand. So first thing I will tell, okay, light is coming from water to glass. Okay, this is the example of relative refractive index. So water to glass, now see what I will write, okay, I can write mu also, I can write eta also. Light rays coming from water going to glass, or you can write first glass then water, you can write like this also. Okay, glass water. So refractive index glass water, what is this one? Now this is nothing but you can write glass, refractive index of glass by refractive index of water. So just now we calculated refractive index of glass is how much? That is your 3 by 2, and this is your 4 by 3. Now here how much? If you will check this one, it will come 9 by 8. Okay. So if a light ray is going from water to glass and you want to find the relative refractive index, then after what it is? It is your 9 by 8. If you glass to water, then it is 8 by 9. Okay. If same thing I am telling, if water is going from, so okay, let us write here number 2, if it is going from glass to water, glass to water. So what will write? Now light is coming from glass going to water. Okay, like this you understand, coming from glass going to water. So how much it is? Water glass. Okay. Now always remember, here this is the second medium, this is the first medium. First medium means from where it is coming, that is first medium. Where it is going, that is second medium. Okay. So that one you must remember. This is your first medium, medium 1, this is your medium 2. Okay, that's why you are writing it is 2, 1, like that type of medium you are writing. Now here what I can write? Now I can write here it is water divided by eta glass. So this is nothing but how much? It is your 4 by 3 and it is your 3 by 2. If you will write this one, it will come 8 by 9. Okay. Or you can write also water to glass is equal to nothing but 1 by glass to water. That also you can tell about this refractive index. Okay. So this idea, remember, relative refractive index, how to find water to glass or glass to water coming, then your refractive index will be like this. Similarly, other things also you can find it out. Okay. Understand another point regarding this refractive index. Suppose you want to write refractive index of 2, 1, then you can write refractive index of 2 by 1. That means what it is telling? It is telling light is coming from 1 going to 2. Then you can write like this 2, 1. Then that is what basically refractive index of 2 medium, second medium by first medium. Okay. Now here the second medium refractive index, if you normally absolute refractive index will say it is C by V2 divided by it is C by V1. Now I can write C will get cancelled, I can write V1 by V2. That means here what I am relation getting? Eta 2, 1 is nothing but that is V1 by V2 or eta 2 by eta 1. Okay. Now another expression I want to include there. Now understand, light ray when traveling, then what you can write? You can write velocity of the light is nothing but that is frequency into lambda. Okay. Or you can basically speed is basically this is frequency to lambda. So this will be what? This will be frequency and this will be wavelength. This will be wavelength. Okay. So light is a wave, so frequency to wavelength will come for the light. So V equal to F lambda. Now here you see, so V is basically what coming now? V is coming directly proportional to lambda. V is coming directly proportional to lambda. Now here I can write V1 is nothing but lambda 1, V2 is nothing but directly proportional to lambda 2. So you can write lambda 1 by lambda 2. Or you can write basically F times lambda 1, F times lambda 2. And remember this frequency F, it remains constant, okay, in refraction. In reflection also it is constant, in refraction also constant. That means whenever light ray is going from one medium to another medium, okay, so here what will happen? If its wavelength is lambda, here wavelength will become lambda prime. If it is frequency F, frequency will become same F. Its velocity V, its velocity is V prime. And if it is intensity I, then its intensity will become I prime. That means what is happening, understanding? If light ray from this is the first medium, this is the medium number 1, this is the medium number 2. Okay. If light ray from the first medium, intensity I, velocity V, lambda, wavelength, frequency is there. Okay, everything will change except frequency. Frequency will not change. Okay. So that means basically frequency basically tells about also sometimes you can tell it the characteristics of color. Okay. So suppose you take water and put light, red light. When red light will go inside this water, it will not become blue light, right? So that's why it will become red light only. So that's why frequency is not telling the characteristics of color. So frequency. So this is the idea you are understanding. Now here refractive index 1 2 you are writing, you can write like this way. Okay. Now second thing understand. So you can remember frequency remains constant in refraction, it does not change. Okay. Another thing understand, N21 is equal to 1 by N12. This one also you can understand. Okay. So this is the thing is coming. And another some relation, remember what is the relation I am telling. Now suppose you want to write a refractive index of 3 1, okay, medium 3 with respect to medium 1, then you can write refractive index. What you can write? This one you can write basically refractive index of 3 by refractive index of 1. Now little modification I can do here. Now you can do refractive index 3 by refractive index of 2 into refractive index of 2 by refractive index of 1. So, you can do like this. Okay, now here this is nothing but what? Now, this is a refractive index of 3 2 into refractive index of 2 1. So, in this way you can write refractive index of different mediums. Okay. Or suppose you want to write refractive index of glass with respect to water, then you can write refractive index of glass with respect to glass by refractive index of water, then you can write this one as glass water is nothing but refractive index of glass with respect to air, write air with respect to water. So, this way also you can write. Okay. So, this is the proof you can do here. So, end to end you are multiplying, you are writing this way. Okay. Suppose you want to write 3 2, similarly you can write 3 by 2 and you can put 1 medium, then you can accordingly you can write. So, whatever you want you can do this here. Okay. Glass to water writing means first glass refractive index by water refractive index, then in between you can use air medium. Okay. So, you can use air, divide air, multiply air, then you will get refractive index of glass to air into air to water. Okay. So, always remember if 2 by 1 is there, you write it 2 1, 3 by 2 is there, you write 3 2. That means it is telling basically light ray is coming from second medium going to third medium. Okay. So, in this you will remember light is coming from 1 to going to, this 1 is here, this 1 is here. Okay. So, light this way means light is coming from 1 going to 2, coming from 1 going to 2. Okay. So, this is the idea you are understanding about refractive index. Now, some questions will see under this. Now, Farmer point understand here Cauchy's equation. So, what this equation tell? Now, refractive index, okay, that you can tell eta refractive index is nothing but how much? A plus B lambda square plus C lambda fourth plus dot it will go. Okay. So, this is the relation you can remember between refractive index and wavelength, but just normally we know refractive index is basically inversely proportional to velocity and also inversely proportional to lambda. Okay, this one already you know, but here remember from Cauchy's formula this thing is coming and A, B are little constant coming here. So, remember if refractive index variation coming and these options are there, then you choose this option as compared to only 1 by lambda. Okay. So, this idea you can just remember. And one more thing remember, refractive index has no unity, no dimension. Refractive index has no unity, no unity and dimension or dimension less. So, dimension less and has no unity. Okay. So, here because speed by speed, so speed by speed is nothing but dimensionless. Another thing understand here that is your dependence. So, under what it depends? So, dependence of refractive index, the first point remember it depends on the basically what? Now, wavelength. First of all you can write it depends on the wavelength of light. Okay. Second thing you can remember, okay, it depends on the medium. Okay. Medium. Number 3 you can write depends on the temperature. Okay, remember if temperature increases, refractive index will decrease. Okay, if temperature increases, then refractive index will decrease. So, this is your idea or understanding. And remember this refractive index is basically optical density. It is called normally basically optical density. So, this optical density is very different as compared to mass density. Okay. So, remember always what can happen. Suppose I am taking one material that is called turpentine and one is called water. So, remember these two material, turpentine mass density is less. Mass density means mass per volume. For water, mass density is more as compared to turpentine. But remember, refractive index or optical density of this material will be more as compared to optical density of water. Okay. So, it does not mean that if density of a material is more, that means mass density is more, its optical density is more, not like that. It depends on the material. Okay. If here mass density also less, but its optical density is more as compared to water. So, this point you just remember. Okay. And one more thing remember here, this temperature dependence also for refractive index. Now, we will go to the next thing, that is principle of reversibility. What is this one? Now, normally whenever we are doing one reflection or refraction, then after here we are telling this is our incident ray, this is our reflected ray or refracted ray. In case of reflection, it is reflected ray. Now, this angle I, then this also will be I, okay, or this angle theta means this angle also will be theta, angle of incidence, angle of reflection same. Now, what the principle of reversibility telling? Now, in the same case, if I will keep a mirror here, if I will keep a mirror, the same ray will retrace its path again, in the same path it will retrace and it will come back. Okay, this is called basically principle of reversibility. Similarly, you can see for refraction also. Suppose one material is there and we are putting a light here. Now, this is your angle of incidence I. Now, light is coming with angle of refraction R, and suppose this is your denser medium. This is your denser medium 1, this is denser medium, right? This is your rarer medium. This is a rarer medium. Now, here light rays coming and going here. Now, if I will put a mirror here, then here light ray will go like this way. Light ray will go like this. Okay. So, it will come back. So, this is the idea basically principle of reversibility. That means it states that light will follow exactly the same path if its direction of travel is reversed. Okay. If you are reversing, then it will travel in the same. So, here it is eta 1, here it is eta 2. Then I can write here eta 1 2 is nothing but 1 by eta 2 1. Okay. So, principle of reversibility, you just try to understand. Okay. Now, we will go to the next thing, which is basically questions. So, here they are telling a ray of light, here they are telling a ray of light traveling in air have wavelength, frequency, velocity, intensity. If this ray enters into water, then the same parameters change actually how? Lambda prime, A prime, B prime, I prime. But here it is V, F, lambda, like that type of things is given. Now, which of the following relation is correct? Now, here some options are given. Understand, I told if it is refraction case, if light ray is coming, this is having wavelength lambda, velocity, frequency F, intensity I. When it is going to another medium, this is the medium 1, this is the medium 2, then it is velocity V prime, frequency A prime, intensity I prime, okay, and here lambda is lambda prime. Then after what quantity will not change? Actually frequency will not change, okay, but other quantities will change. That means this V should not be equal to V prime, it will be less actually if it is denser medium, okay, I am telling. Then what it will happen? It will be, this velocity will be less, V prime will be not equal to V. Similarly, okay, lambda prime will be not equal to lambda, and similarly intensity also will be not equal to I. Only frequency will be equal to frequency prime. So, that which of those is correct? Now, this B will be correct. That means frequency remains constant in refraction or reflection, frequency does not change, other quantities will change. Okay. And remember, you know, if refractive index is more, then speed of light in that medium will be less, it will decrease speed of light. Accordingly, you can check about wavelength. Okay. Now, we will go to the next question. Sodium light of wavelength something given is incident on a boundary separating air, glass. If refractive index of a glass is 1.6, then velocity of light in glass is how much? So, here some options are given. Okay, now see, just now I told if velocity of light in any medium you want to find, then you would write what? Speed of light in air or vacuum divided by refractive index. So, here what is given? C is nothing but 3 into 10 to the power 8 divided by, okay, in meter per second you will come answer. Refractive index of glass is given 1.6. So, put it to 1.6 here. Now, how much? 3 by 1.6, that means it is 30 by 16, okay, 10 to the power 8 meter per second. So, that means it will come around not exactly 2, little less than 2. So, little less than 2 means you can write here how much it is. It is here 1.875 into 10 to the power 8 meter per second. You will calculate this one, you check here, it will come 1.875 into 10 to the power 8 meter per second, which is the velocity of light in the glass medium, particularly for this question. Okay. If velocity of if refract index they are changing, then light velocity in the glass it will change. Okay. So your answer will be what? Option C. Answer will be option C. Now we will go to the next question. Okay. Now the refractive index of water with respect to air is 4/3. Now see what I told. Now refractive index of water with respect to air. With respect to air means light is coming from air going to water. This is the condition. That means you can write also it is water comma air. So this is nothing but how much? This is your 4/3. That is also can be written as refractive index of water by refractive index of air. This is 4/3. Now the refractive index of a glass with respect to air is 3/2. So now they are telling here light is coming from air going to glass. That is how much? You can write it is glass comma air. Okay, how much it is? It is 3/2, or you can write it is your glass, it is your refractive index by air. Okay. So this is the thing is given, but question asking what? Now refractive index of water with respect to glass. That means your question asking refractive index of water with respect to glass. That means refractive index of water, you have to keep water here. With respect to glass means light is coming from glass. Okay, light ray is coming from glass going to water. Now here you can write this one as water by glass. You can write this one as water by glass. So this one you need to find it out. That's all. Okay. So what you can do here? Now if you divide these two equation, okay, then you can get water by glass. We can get here. If you divide these two equation or these two relation, if you divide it, then directly we will get. So let me write here, that is equal to nothing but 4/3/3/2. If I will divide this, because you see air will get cancelled, so water by glass will remain here only. So here 4/3/3/2. So this 2 will go up, it will become 8. 3 into 3 will become 9. So whatever they are asking, answer will be what? 8/9. Now check your options, 8/9, 9/2 and 1. So answer will be option A, which is 8/9. Okay. Some other method also you can do, but in this also you can try. Okay, if I dividing these two, then air cancelling, water by glass, which is coming basically 4/3 into divided by 3/2, then 2 is going up, it is becoming 8 and 3 becoming 9. Okay, so 8/9. I hope you understand. So this is the idea about the refractive index and refractions. Okay, in the next video we will be discussing more concepts on refraction of light. Then after we will solving some NEET MCQs and practice MCQs also. Keep watching the video. Okay, I hope you understand all the concepts here. Okay, thanks for watching. Like and subscribe Vidhyalakshmi NEET Academy YouTube channel. All the very best. Thank you so much.